What if I told you that there was a way that you could control aspects of your game using your microphone as the controller? Well, that's exactly what we're going to be talking about in today's video. And while to some, this may seem like just a fun and quirky concept, to the millions of gamers out there who use accessibility options, this could determine whether they're able to play your game or not. So let's jump over into Unreal Engine and take a look at how to set this up. Now, I am in the first person template. The template that you're using, or if you're starting from scratch, that doesn't matter. What does matter, however, is that you're using at least Unreal Engine version 5.3 or newer. And the reason for that is because when setting this up, we're actually going to be using the Metasound output subsystem to make this all come together. And we are going to take kind of a Mr. Miyagi wax on, wax off approach to this. I'm going to show you something very simple and basic, and then we'll talk about kind of how to expand on your own outside of that. So what we're going to do is I'm going to set up a ball on this little podium, and basically we're going to use the amplitude coming into my microphone to make it bounce up and down. And so to do that, inside of our content browser, I do already have a folder here called Voice Activate, just so we can keep all the tutorial stuff together. However you structure your content folder, though, is entirely up to you. And we're going to right click here, and we're going to go to our blueprint class, and we're going to create a blueprint actor. And I'm just going to call this ball. And if we open up this blueprint, we're obviously going to need a ball. So I'm just going to grab our sphere here, and I'm going to move this up just to help with clipping through the floor. And then what we need to do is we need to give this ball the ability to listen. And so we're going to do that by coming over here to our components and clicking on add, and we're going to look for audio capture. And you can name this whatever you want, but just for the sake of tutorial, I'm going to keep this just named audio capture. And with it selected, there's two things that we need to do over here in our details panel. The first thing that we need to do is we need to come down here to our base submix, and we're just going to go ahead and create a sound submix. So I'll just call this submix underscore ball. And if we open it up, the only thing that we need to do in here is we're going to come over here to our output volume, and we're just going to turn it all the way down. And the reason that we're doing this is because if we didn't change that value, or we didn't use a submix at all, once we got into our game, anything that comes into your microphone, you're actually going to hear back out of your speakers. And for this example, we don't want that. So all we're doing inside our submix is just essentially muting that output. And so we can save that and close it, and we don't need that submix anymore. The next thing that we're going to do is we're going to come down a little further under our pre-effects bus send, and we're going to add an element, expand this out, and then under audio bus, we're going to create a new audio bus. And I'm just going to call this AB underscore ball. And we actually don't even need to do anything inside this now. We're going to be using the audio bus reader node inside of our Metasound, and we just need a channel to send this to. Now, if we do open it up, by default, we do have the option to use multiple channels, but since we're just using a single microphone input, the mono is all we need. So we can save that and close that out as well. Now, the next thing that we need to do is, like I said, we're going to be using our Metasound output watching subsystem. So we need to actually create that Metasound. So again, back inside our content browser, I'm going to right click, and we're going to look for a Metasound source. And I'll call this MSS underscore ball, so that we know that it's our Metasound source that we're using for that ball. And now we'll go ahead and open that up. We won't need the on finish, so we can go ahead and delete that. We do need the on play because we need the meta sound to be active in order for this to work, but we don't actually need our audio output. Instead, what we're going to do is we're going to go ahead and right click here, and we're going to search for audio bus. And like I said, the audio bus by default is mono, so we just need this audio bus reader 1 so that we're on a mono channel. In our drop down, you'll find that audio bus ball that we created. And now we need to do something with this output. I would recommend running this output to a mixer. And the reason being is I'm going to leave this 1 for now, but we are going to be adjusting this gain level in just a little bit. From our mixer, we're going to run into an envelope follower. And the reason for that is we want to take this audio signal and convert it to an envelope float value. If we were to use just the audio output, we're going to get both positive and negative values. But with the envelope follower, we're only getting positive values. And we're just going to promote this to a graph output. You can name this output whatever you want, but just for the sake of tutorial, I am going to keep it envelope. And now if we come back into this blueprint that we created, we're going to come back up to our components, and we're going to add an audio component. Now, because I do still have that meta sound open, it's going to essentially suggest that we're adding that meta sound source for the ball. But if you, for some reason, don't have that reference, or you need to make it something different, you can just click on it, and then in the details panel, you can change that sound to whatever meta sound you want. And so we'll go ahead and compile this. And as far as our viewport, we're done. We're going to move over to our event graph, and we can get rid of the overlap as well as the tick, because all we need is this event begin play. And we're going to use this event begin play to start our audio capture. So I just grabbed a reference of our audio capture and pulled it into our graph. And if you were to drag off this and type start, you will find under synth components audio, you will find start. And if we connect this to our event begin play, basically what this is doing is it's telling our blueprint, when you spawn, start listening. And so now we need to tell it what it's listening to. So, and this is where, as I mentioned, you have to be using at least version 5.3 or newer, because we're going to right click on here and we're going to look for our Metasound output subsystem. And so with our Metasound output subsystem, we need to tell it what to watch. So we're going to watch an output. And as I'd mentioned, we called this output envelope. It doesn't matter what you name it, just so long as we're able to copy the name and put it right here into our output name. We're going to grab that meta sound that we added as a component, and we're going to connect that to the audio component. And we want this to start watching at the same time that it starts listening. So we'll go ahead and drag our execute pin through here. So now we've got a nice signal flow from event begin play, start listening, start watching. And so now we're going to come out of our on output value change, and we're going to create a custom event, and I'm just going to call this bounce. And because this is a float output, from our output, we're going to say get float, and the execute pin should connect automatically, which is what we want. If it doesn't, just drag it over and connect it. And so now, as long as you can get to this point, this is where you can really start to take off and do whatever you want with this. But like I said, we're going to make this ball bounce using the amplitude that is coming into our microphone. And the way that we're going to do that is we're going to get a reference to specifically the ball, and we want to set the relative location. We want this to change every time this value changes, so we're going to pass through our execute pin here. And since we only want it to bounce up and down, we can split this out because we're just going to need our z-axis. Now, technically, you could pass this directly to the z-axis. The issue with that, though, is this output is a value between 0 and 1. So if we're just directly passing 0 to 1 to our z-axis, you're not even going to notice it moving. So what we want to do is instead, we're going to come out here and we're going to do a map range clamped. And we'll just go ahead and connect that up. And so inside of our map range, we do know that our envelope is between 0 and 1. So we could keep our in range A as 0 and our in range B as 1. And that will give us the full spectrum of that envelope. Now, I will say that I would recommend playing around with the in range A value. And the reason for that is if we're accepting everything, that means anything that is making noise around your microphone, everything from, you breathing into your microphone, maybe accidentally sneeze or something, even the AC kicking on in your room, this is all audio that is going to go into your microphone and cause this ball to move. And so think of the in range A as kind of a gate. So if we adjust this value, it's like adjusting the threshold of that gate. And so I'm actually going to change this to 0.05. You may need to change it to something different depending on your microphone. But for my particular setup, I did find that 0.05 is a good kind of threshold for that. Now our out range, this is going to be essentially the height of our z-axis that we're manipulating that ball to. And so again, this is going to be dependent on whatever you want to set it up as, but just for the example, I'm going to set this to 1000. And now from a general standpoint, this is finished. So again, as soon as this spawns, we're going to start listening and we're going to start watching. And we know that we're listening through this audio capture. We know we're watching this meta sound. And we also know what output specifically on that meta sound we're watching. So we're going to take that float value, and as long as it's between 0.05 and 1, it is going to move that ball on the z-axis between 0 and 1000 units. And so if we compile this, save it, and we'll just move all this out of the way. Let's go ahead and drag in our ball blueprint. And if I hit play on this, you see that we have our ball there, and it doesn't appear to be moving. Now, just a headphone warning, I am going to get a lot closer to my microphone, so it may be a little louder. But if I get right up on my microphone, you can see that it does actually move. So how do we fix that? Well, if we jump back into our meta sound here, this is where I mentioned adding this mixer. And so if we turn this up, we are essentially adjusting the sensitivity, sort of. It's a combination between this in range and the gain here. So I'm going to bump this up to, let's say 5. And if we save that and move this back out of the way, I'm going to move this up just a little bit more. And so now, as I talk, I'm not as close to my microphone, and you can see that that ball is now reacting to the voice that is coming into my microphone. And the louder I get, the higher it goes. And so now that we've done that, you can see that we can apply this to other things. So for example, now I can adjust the intensity of a light based on my voice that's coming into the microphone. And you'll see if I open this up, I'm actually still just using the same ball blueprint. Everything here is exactly the same as it was. It just now, instead of getting a reference to a ball and changing its z-axis, we're using a spotlight and we're just adjusting the intensity. And so you can see now how you're able to basically expand on this. We started with just making a ball bounce, and then we moved into changing a light intensity, and you can really start to get creative with however you want to use this. Now there's also something really fun that we can do with this, and if we jump back over to our Metasound, you remember this output that I said we didn't need. And for the sake of controlling aspects inside your game, you don't need it. But we can still have a little fun with it. So if we bring this output down here, I'm going to run this to, let's just say, a bit crusher. And if we run this audio out to that bit crusher, save it. And now if we hit play, check. So there's that. Now you hear my voice doubled because OBS is recording through my interface as well as it's picking up game audio. So if you are wearing headphones, you wouldn't hear that necessarily doubled. If you were playing it yourself, I mean, you would hear yourself talking and then the bit crusher. There is a little bit of latency in there, but let's say you were setting up a game with proximity voice chat. You can put an attenuation on this and you can apply effects to it. And so then as you get closer to other players, maybe, you sound like you're coming through a walkie-talkie, or you can add compression or dynamics to your voice and change how your voice sounds to other players in your game. So you are effectively running your voice into a Metasound and processing it in real time. But that is going to wrap things up for this video. Hopefully you guys found it informative. As I mentioned, the core concept for this is to offer accessibility options to those who may need them, and really just kind of help create a more inclusive gaming community. But then, with the voice effects being processed in real time through Metasounds, we can also have a lot of fun while doing it. So if you guys like this video, make sure you hit that subscribe button along with the notification bell so you never miss out on any future content. And if you'd like to be a part of the Sound Effects Guy Discord server, you will find a link in the description below. Until next time.